All right, we're back at it with review set 2. We're going to start with number 3 in your packet, and now I'm kind of set on what my system's going to be. I'm just going to do a bunch of review questions, post them all as individual videos, and whoever watches them watches them. So we're going to start, or what review set 2 is all about is scatter plots. And the big idea, remember, from this year is we start with one variable data, a singular data set, and we know that we can find statistics about that, like the mean and the median. We can make graphs from it, like a histogram or a box plot. But then the second unit of the year was 2 variable data, or what happens if we have 2 variables. And we know that we can make a scatter plot. That's the big graph for these. And the way that a scatter plot works is you have one variable on one axis, one on the other. But there's a second kind of graph or thing that we can have too, and that is a two-way table. Okay, so the first question we're going to go over is going to cover both those things. And two-way tables are really easy. And I honestly have a feeling this whole unit's not going to be on the AP exam. One reason is that this unit is revisited at the end of the year with chapter 9, and the exam this year is only covering 1 through 7. So there's like a whole half of this unit that isn't even fair game to be on the test this year. And because it's only a 2-question test, like if I had to be a gambling man, I'd say that the exam is going to cover unit 1, then inference, and then probability. Those would be the 2 questions. But we still got to know this, and this stuff's actually the easiest stuff. It's kind of the most fun. So that's kind of not interview, or interlude, I guess, intro. So let me read the question. It's on the next page, but it says the following scatter plot shows the size in square feet and selling price in thousands of dollars for a sample of 30 houses for sale in a certain area. So it's trying to see basically, is there a correlation between how big a house is and how much it costs? And I mean, the answer, duh, in real life. And we can see that that's the correlation. It's positive and moderate to strong, probably strong, I would say. There's not even any real outliers. Okay, and then A says describe the association shown in the scatter plot. And sometimes there's multiple words, and I have a tendency accidentally to say one of them more than the other. But association is the same thing as correlation. Okay, and the opposite of that is independence, and we're going to get to that later in the question. But if you see association, describe the association, describe the correlation, they both mean the same thing. And those are those big words. So I guess before I even answer this, remember that if we're going to describe correlation, that's like the describe a distribution in a few sentences kind of for this unit. And you either want to say it's positive or negative. And then weak, moderate, or strong. And again, I mean, the beginning of the year was a lot easier, and hopefully we were like, oh yeah, this stuff was really easy. Then the other thing is we could say linear versus nonlinear. That nonlinear stuff is kind of what some of the later part of the year was, and it is possible that you could have like a U, like a parabola or exponential, but lucky for us, this question won't have that, almost certainly. So if it's just saying describe the association, write all these down for your notes for when you take the test, but you're going to basically say it's positive because as one goes up, the other one goes up. It's strong or moderately strong. We're going to say moderately strong, and then it's linear, okay? The association is positive and linear. It is moderately strong. So like there's 3 words, but we can be wizards here and turn it into 5 words where we could have weak, moderately weak, moderate, moderately strong, and strong. Don't say weakly moderate or strongly moderate. Those don't make sense. But yeah, you could have 5 words here. And if I was to say what's the correlation coefficient here, it's got to be like 0.7 or 0.8. Okay, and we'll cover another question similar to that. But remember that in percent, there's R and there's R squared. Those kind of tell you the correlation. So the reason I'm starting with this is it also shows us a two-way table. And it says in the region, houses are considered large if they are greater than 2,500 square feet and expensive if selling greater than 300,000. Okay, the following two-way table summarizes the houses in the sample. So all this is doing is it's taking our 30 data points, and instead of showing the whole range, it's actually turning that into categorical data. And what I mean by that is it's saying that some value, in this case 2,500 or greater, is considered a large house, and the ones smaller than that are considered a not large house. Okay, so categorical data can be like two different types of categorical data can become a two-way table, and we can do probability with this. We're going to cover that in the next review set, and that's actually like for sure the easiest stuff we have to do. But this is the two-way table, and it's saying use the information to construct a graphical display. Okay, and if you have to do a graphical display of a two-way table is always connected to a segmented bar graph. Okay, and this is kind of the last type of graph. Like we deal with the normal distribution and like distributions in the future, but as far as graphs go, unit 2 adds us the scatter plot. It gives us this graphical display, the two-way table, but then the final thing is called a segmented bar graph. Okay, and all that is, and it's not a histogram because this is categorical data. There's large versus not large. But if we want to make this segmented bar graph, we don't even need multiple colors here. We just can have a shaded versus not shaded. Okay, and one of your variables is going to go on the bottom. Okay, so we can say large and not large. And this is one of those things I'm writing a lot and then I will clarify. But the first variable we can put here. And we know that 12 of the houses are large and 18 of the houses are not large. So that's as high as up as we have to go here. The frequency for large is 12 and the frequency for not large is 18. I'm going to go with 3 going up. So those are my two bars, and this is what a graph from like the first unit could look like. But because we now have two things of data, we also need to represent how many of the large houses are expensive and how many of the houses are not expensive. Okay, so that's where the second thing comes in. First variable, just put it on the graph if you ever get lost. Second variable is going to split up those two bars. Okay, so out of those 12, 8 were expensive. So a third of the way down from here. And do you guys see what I mean? This many were expensive, this many were not expensive. But so now we're going to say the not expensive are the top 4 and the expensive are the bottom. Then for the not large, and this kind of all makes sense, right? The expensive house is not large. This is our Cali homies spending a fortune on nothing. But most of the not expensive houses are not large. You know what I mean? So 2, and we got to keep it consistent. If we have the shaded on the top here, we want to keep it up here as well. 2 of them are not expensive and 16 of them are expensive. So that is our graphical display from this unit, and there's actually not any other time it would ask for a graphical display. And if the AP asks any of this stuff, like, you're golden. Like, we should get full credit here. Make sure you have your labels though. Let me just make sure there's not a second section portion of this. Jesus Christ. Did I even read this whole question? Okay, that's fine because we're going to skip the second half because it's not the unit. Okay, so now let's go on to 2. It says, assume there's no association between size and price Use the given totals to complete the following table with the expected number of houses for each classification if there was no association. So I'm going to very quickly draw it over here because it got split in between the two pages. Okay, so for the second part of this, it's saying that we're going to assume that there's no association between being expensive and being a large house. Okay, and the opposite of that is what's called independence. I guess it doesn't even say that, but we are supposed to now fill this table in. We already know that there's an association. Like clearly the expensive houses, clearly the expensive houses are I messed this up. Oopsies. Okay, so that's what it's supposed to look like, and clearly the not large houses are also not expensive. But what we want to see here is if there's no association, that means the proportion of the large houses and the not large houses are the exact same for whether or not they're expensive. So what I mean by that is the ratio is going to be identical for both of these. And once we plug in a few values, this should make sense. We've done questions like this before. It could also ask us, like, is there independence between the two? And the best way to approach this, the math can be a little tricky and it'll be useful to have these notes, but we see that the ratio here is 12 to 18. Okay, so we want that same ratio to be present with these numbers as well. And so all we have to do is figure out what that ratio was before. So if it was 12 divided by 30, so 40%, then we have to have that ratio match these as well. Okay, so again, here's how we want to think about this. We just need the ratio to be the same for all of these. So if it was 12 to 30 before, we need to figure out what out of 20 gives us 40%. Okay, so we can do just 20 times 0.4, and that's 8. And then by deduction, this would be 12. But this divided by this is the same thing as this divided by this. And then we can do the same thing here. It's going to be 4 and 6. But if there's no connection at all between if a house is expensive and if it's large, this is what that graph is going to look like. Okay, so keep this reference, but a big key to this is that you want to make sure the ratios are the same. And when you do it right, you'll feel pretty confident. And then another reason I'm doing this question, and this video isn't too long, so that's good, is to show you stuff that we didn't learn, but not to be worried because it's not going to be on the AP. Okay, so Unit 8, we've talked already in this about Unit 9, but Unit 8 is called chi-squared, and that's doing inference for two-way tables, and it's actually really cool. I know a lot of people did it in bio, and I really like it, but it's not going to be on the AP this year, so this whole second part, you're good to not do, okay? And I'm going to warn you if there's parts of questions that you get to skip, but again, this scatter plot unit, about half the stuff we were going to come back to at the end of the year, so I wouldn't expect it to be on the AP. Okay, so that was the first question. I'm going to post another video probably right away of the second one, so woo!